Hello, I am Sunita. Welcome to my class. Here I am going to discuss TPSTR science topics according to this year syllabus. Here the topic is circular motion. In that one, centripetal and centrifugal force. Let us start the class. Let us discuss here one of the important topic, circular motion. Circular motion, motion of a body along a circular path is known as circular motion. If a body is moving along a circular path, then that type of motion we will call it as a circular motion. Let us discuss in detail about circular motion. Circular motion is described as a movement of an object while rotating along a circular path, otherwise motion of an object along a circular path. Circular motion can be either uniform or non-uniform. During uniform circular motion, the angular rate of rotation and speed it will be constant. You have to remember here, in the case of uniform circular motion, angular rate of rotation and speed it will be constant, while during non-uniform motion the rate of rotation keeps changing. But in the case of a non-uniform motion, the rate of rotation it will be go on changing. Some of the most common example of circular motion include man-made satellite that it will revolve around the earth, then a rotating ceiling fan, a moving car wheel, the blades in a windmill and gears in a gas turbines. These are the few examples of circular motion. Next one, uniform circular motion. The motion of a body moving with a constant speed along a circular path is called uniform circular motion. Here, in the case of uniform circular motion, you have to remember the body is moving with a constant speed. But here one thing you have to remember, here the speed is constant but the velocity it will be go on changing, because if when you are considering velocity you will consider direction also. Then here when the body is moving in a circular motion, each and every point the direction of the body it will be go on changing. When you are consider the direction, then we will use the term velocity. Then velocity it will be continuously changing each and every point. Therefore in the case of uniform circular motion, speed it will be constant but velocity it will be go on changes in each and every point along a circular path. First one note. So if a particle is moving in a uniform circular motion, first one, its speed is constant. Always remember, in the case of uniform circular motion, speed is constant. Second one, velocity is changing at every instant. When you are considering velocity, you will consider the direction also. When the object is moving in a circular path, each and every point it will change its direction. Therefore, automatically the velocity it will be go on changing. Third one, there is no tangential acceleration. First learn what is meant by a tangential acceleration. Tangential acceleration is defined as the rate of change of tangential velocity of the matter in the circular path. Here tangential acceleration is nothing but rate of change of tangential velocity of the matter in the circular path. But in the case of a uniform circular motion, there is no tangential acceleration. Here you will identify only the radial acceleration. Fourth point, radial acceleration it will be equal to W2R. Then what is meant by radial acceleration? In a uniform circular motion, the acceleration of the object is along the radius directed towards the center is called radial acceleration. In the case of a uniform circular motion, the acceleration of the object along the radius directed towards the center, acceleration it must be along the radius and directed towards the center. That one we will call it as a radial acceleration. In the case of uniform circular motion, we will identify radial acceleration but tangential acceleration is absent here. Then fifth one, V is equal to WR. V means linear velocity, W means angular velocity. Linear velocity means when the object is moving in a straight line, then we will consider a linear velocity. When the object is moving in a circular path, we will consider angular velocity. Let us discuss few examples on uniform circular motion. First one, motion of artificial satellite around the earth is an example of uniform circular motion. Here the gravitational force from the earth makes the satellite to stay in the circular orbit around the earth. Here you know earth is having a gravitational force. Because of its gravitational force, the satellite it will be revolve around the earth in a particular orbit. Second one, the motion of electrons around its nucleus. You know the electrons it will be revolve around a nucleus in the circular orbit. Third one, the motion of blades of the windmills. The next one, the tip of a second hand of a watch with circular dial shows uniform circular motion. Variables in circular motion. This is the consider an object is moving in a circular path. Then this is the center of the circular path. This is the radius of the circular path. Then here consider 2 points A and B. The angle made by these 2 points is delta theta. Then here ds is the displacement between these 2 points. Then angular displacement is equal to the angle which is subtended by the position vector at the center of the circular path. Unit is radian. The angular displacement theta it will be equal to ds divided by r. Here ds is linear displacement, then r is the radius. Then next one, angular velocity, rate of change of angular displacement. Angular velocity is nothing but rate of change of angular displacement. Unit is radian per second. Angular velocity w it will be equal to d theta divided by dt. Linear velocity v it will be equal to rw. Angular acceleration is nothing but rate of change of angular velocity. Angular acceleration a it will be equal to delta w divided by delta t. Unit is radian per second square. Linear acceleration a t it will be equal to r into a. Then centripetal acceleration that acts on a body in a circular motion whose direction is towards the center of the circle. Centripetal acceleration is given by AC, it is given by v square divided by r. Centripetal acceleration is nothing but acceleration that acts on a body in a circular motion. That acceleration is always pointed towards the center of the circle. That one we will call it as a centripetal acceleration. Let us consider non-uniform circular motion. In this case, the object it is moving in a circular path, but this object it will be each and every time it will change its direction of velocity, also magnitude of velocity, even the acceleration speed, everything it will be changed when it is moving along a circular path. Then you can identify two types of acceleration here. One is radial acceleration, another one is tangential acceleration. Radial acceleration it will exist because due to change in direction of velocity. When the direction of velocity changes, in that case you can identify radial acceleration. Then tangential acceleration due to change in magnitude of velocity. Magnitude of velocity is nothing but change in the value of the velocity. Then here radial acceleration always it will point towards the center of the circle or along the radius of the circle. Then tangential acceleration it will exist only in the change in velocity of the object. But here one thing you have to observe, net acceleration is no longer pointing towards the center of the circle. Therefore, in the case of a non-uniform circular motion, you can observe a change in speed also, change in velocity also, change in acceleration also. Each and every point it will be go on changing. This type of motion we will call it as a non-uniform circular motion. the difference between uniform circular motion and non-uniform circular motion. In uniform circular motion with constant angular speed is known as uniform circular motion. Here, circular motion means the motion of an object in a circular path. Here, in uniform circular motion, angular speed of an object, it will be constant throughout the motion. In non-uniform circular motion with variable angular speed is called non-uniform circular motion. But in the case of non-uniform circular motion, angular speed, it will be go on changing each and every point on the circular motion. Then second difference, for uniform circular motion, acceleration it will be 0. For non-uniform circular motion, acceleration is not equal to 0. That is the second point. Third one, in uniform circular motion, work done by tangential force is 0. Work done is 0. But in the case of non-uniform circular motion, work done by tangential force is not 0. Then see the example. For uniform circular motion of the earth around the sun, because the earth, it will be revolving around the sun in the circular orbit. Next one, non-uniform circular motion of a body on a vertical circle. These are the few difference between uniform circular motion and non-uniform circular motion. Defining centripetal force. When the object is moving in a circular motion, then the object, it will possess a centripetal force. This centripetal force, it will pointing towards the center, otherwise it will be acting along the direction of the radius. Centripetal force is the force acting on an object in the curvilinear motion directed towards the axis of rotation or center of curvature. Calculating centripetal force. The centripetal force formula is given as the product of mass in kg and tangential velocity squared in meter per second and divided by radius in meters, which implies that doubling the tangential velocity. If you double this tangential velocity, then the centripetal force will be quadrupled. Mathematically, it can be written as F, it will be equal to mv square divided by r, where F is the centripetal force, m is the mass of the object, and v is the speed or velocity of the object, r is the radius. Centripetal force is nothing but central seeking force. This force is acting towards the center of the circle or along the radius of the circle. That one you have to remember. Centripetal force examples in daily life. The centripetal force pulls or pushes an object towards the center of a circle as it travels, causing angular or circular motion. Some example of centripetal force are given below. Centripetal force is nothing but when the object is moving in the circular path, then that object, it will experience a force, and that force is pointing towards the center of the circle or along the direction of the radius. Then here consider an example. Spinning a ball on a string, the force of tension on the rope pulls the object in towards the center. Here spinning the ball on a string, then the force of tension on the rope, it will pull the object towards the center or along the radius of the circle. Then consider second one. Turning a car, a centripetal force is provided by the frictional force between the ground and the wheel. When the car is moving in a circular path, then the car, it will experience a frictional force. Frictional force is nothing but the opposing force. It will oppose the motion of the car. Then the frictional force it will exist between the ground and the wheel of the car. Because of this frictional force, the car will tend to move towards the center of the circle. Then the force it will experience on the car, it will make the car to experience a centripetal force towards the center of the circle. Next example, going through a loop on a roller coaster, the force is provided by the normal force as the seat or wall pushes you towards the center. Then here Next example, planets orbiting around the sun. Here the centripetal force is provided by the gravity. You know Earth is having gravitational force. This force is pointing towards the sun. It will act as a centripetal force. Let us study centrifugal force. Centrifugal force is a pseudo force in a circular motion which acts along the radius is directed away from the center of the circle. Centrifugal force is nothing but a pseudo force. It will exist when the object is in circular motion which acts along the radius but it directed away from the center of the circle. This is the centrifugal force, opposite of centripetal force. The force does not exist when measurements are made in an inertial frame of reference. It only comes into play when changing your reference frame from a ground or inertial to a rotating reference frame. This centrifugal force you will observe in the frame of rotating reference frame. The centrifugal force unit is Newton. Centrifugal force, if it will be equal to m into v square divided by r, then if it will be equal to m into, substitute in place of v, w into r whole square divided by r square divided by r get cancelled. Therefore f it will be equal to m into w square r. Once again, centrifugal force is a pseudo force in a circular motion which acts along the radius is directed away from the center of the circle. Calculating centrifugal force. A centrifugal force basically uses the centripetal force formula which describes a real phenomenon and reverse the direction of force to describe the fictitious centrifugal force. If it will be equal to minus mv square divided by r. Here negative sign it will indicate centrifugal force is opposite of centripetal force. Centripetal force, the force is acting towards the center of the circle, but in the case of centrifugal force the force is acting away from the center of the circle. That's why here we have to use negative sign, where F is the centrifugal force, m is the mass of the object, v is the speed or velocity of the object, then r is the radius. Centrifugal force examples in daily life. Centrifugal force acts on every object moving in a circular path when you viewed from a rotating frame of reference. You can observe centrifugal force when the object is moving in a circular path. One important thing, when viewed from a rotating frame of reference, you have to consider a rotating frame of reference. That one is very important. Some examples of centrifugal force are given below. Weight of an object at the poles and the equator, a bike making a turn, vehicle driving around a curve, then equatorial railway. Let us discuss the difference between centripetal and centrifugal force. Centripetal force. Centripetal force is the component of force acting on an object in a curvilinear motion which is directed towards the axis of rotation or center of curvature. Centripetal force you can observe when the object is moving in a circular motion. This force is always pointing towards the center of circle or along the radius of the circle. Then centrifugal force. Centrifugal force is a pseudo force in a circular motion which acts along the radius is directed away from the center of the circle. Here also you can observe centrifugal force when the object, when it is in circular motion, this force is always pointing away from the center or along the radius. One thing you have to remember here, centripetal force means the force it is pointing towards the center of the circle. Centrifugal force means the force it is pointing away from the center of the circle. Centripetal force, it is observed from an inertial frame of reference. Centrifugal force, it is observed from a non-inertial frame of reference. Then if a car is traveling through a curve on a circular horizontal road, the centripetal force provided by the force of friction between the tires of the vehicle and the road surface allows the car to negotiate the turn. Then here you can observe when the car is moving in a circular path, then the car it will experience a centripetal force because of the friction existed by the car between the tires of the car and the road surface. Friction is nothing but the opposing force. Because of the friction, the car is always pointing towards the center of the circle. When a car is in motion takes a sudden turn towards the left, passenger in a car experience an outward push. This is due to the centrifugal force acting on passenger. Because centrifugal force, the force is acting away from the center of the circle. Therefore, when a sudden turn towards the left, passenger in a car experience an outward push. This is due to the presence of a centrifugal force that is acting on the passenger. Both centripetal and centrifugal force you can observe when the object when it is moving in a circular motion, that is fixed. But in the case of a centrifugal force, the force is acting away from the center. In case of centripetal force, the force is acting towards the center. Then in the case of a centripetal force, we will consider the inertial frame of work. But in the case of a centrifugal force, we will consider rotating frame of work. That is very, very important. Thanks for listening my class. Send me your valuable feedback.